Hello everyone, welcome to Engineering and Economy. I'm Dr. Nathan. Today we are going to discuss about inverters, the solar PV inverters. The first question is that why we need a solar PV inverters. The solar panels always produce a DC current, it's a direct current. But our house we are using AC current, alternating current. So because we are using alternating current, we need to convert the DC current into AC current. So inverters are doing the job of converting a DC current into AC current. So this is a primary reason why we need an inverter. So let's talk about types of inverters. So we have three types of inverters: string inverters, microinverters, and power optimizer. There's a different function, but we consider is the type of inverter. So uh, general people know only about the inverter, but we are introducing the types here: the string inverter, microinverter, and power optimizer. So let's look at one by one what is mean by string inverter. So string, that's why please go and watch the previous YouTube videos in my channel where we explain what is mean by string. String means a series connected modules called string. Why we always prefer the series connection means series connection will increase the voltage but keep the current as same. If the panels are 5 ampere panels, if we connect 10 panels, we will get same 5 ampere, but the voltage will be added. So that's the reason we always prefer string. So string inverters mean for let's say 20 kilowatt or 10 kilowatt system or 50 kilowatt system, 100 kilowatt system, larger size of system, we need to have number of strings. Then only we can make it that 20 kilowatt or 30 kilowatt likewise. So for those kind of system, we might have three strings. So now the string inverter mean each strings are connected with a particular inverter. That's called string inverter. If you look at this diagram here, the string inverter is this is a first string inverter. It is connected to the particular section of the string here, and the another string here, and another one is here. So this is a string inverter. Okay, so if you go to the large the project site like 500 kilowatt or 1 megawatt system, you can see the string inverters are installed like this. So you can understand the question, like when you are doing the household installation or the rooftop installation about 5 kilowatt or 3 kilowatt system, you may no need to think about string inverters because for let's say 1 kilowatt 2 kilowatt system, we will have only one string. So string inverter, there's no meaning of string inverter because you have only one series connected panels. But when you go for higher size of system like 20 kilowatt system, probably we will have two or three strings. So this is based on how you design your consultant or your solar companies design the panels. Okay, so this is when we go for 1 megawatt, the largest system, we need to have a lot of many numbers of strings. Okay, so the next type is a microinverter. So microinverter are the small unit built in the individual module. So microinverter different is each module we will have a inverter for each module. Separately we have an inverter, that is a microinverter, independent from its neighbors. So now you may ask question why how we can select the inverters, whether say string inverter, microinverter. So it's based on the one thing is based on the project size. If it's a large size, you can have a string inverter, and based on the project location. Let's say if you have a frequent the shading issue on the panels, different panels, then we can go for a microinverters. What I'm saying, even in your rooftop, you're installing 2 kilowatt system, but you have there's a big tree or something is like moving around the places, or some objects are disturbing the solar panels uh, sun radiation, I mean solar radiation. It means that shading issue occurs intermittently. In that case, you are not sure, like you are installed 10 panels, you are not sure which panel is going to get affected by solar shading. In that case, it's better to have a microinverter. So microinverters will take care about each module separately. So it means when you install microinverter, your total output will be high, because microinverter take care about the each module. Because please go and watch the previous video. There we said that if you have you have 10 solar module in series, among these one of the module got affected by solar shading problem, then all the module will have low current rating. So because it's a string means like water flow. So if one of the module affected by this problem, so all the module will have a lowest output. So we want to avoid that problem. That's why we are using a microinverter. So look at this microinverter in this diagram. We have a microinverter. Each module, this is very important, each modules have an inverter. This is called microinverter. We have an inverter, small inverter, but each module have a small inverter. This is a microinverter. Many people do not know about this. That's why my purpose for this YouTube channel is to first thing is introduce the technical terms and tell what is going on, and later you can go deeper, you can study what is exactly um, the importance of microinverters, so you can go for a deeper studies. Okay, so each panels will have a inverter, each panels have an inverter. So this is a microinverter. See that how they install the microinverter. Some place they install backside of the panels, some place they put the inverter here. This inverter belong to this panel, and it's connected nearby the panel by a rod or something installed, and this is your microinverter. Look at here, this is they are connecting behind the panel. They're going to close the panel like this, and behind the panel we have a microinverter. Here is again installed like this. So basically microinverter will optimize, I mean it increase the total output, because each modules are taking care. So let's say one module is shaded, another module is not shaded. So shaded module will provide less current, and the unshaded module will provide more current. So both output converted to AC, and AC output will be added. So the shading issue minimized in the microinverters. So look at these two scenario we have studied so far. First one is string inverter, about the string inverter, and then we studied about the microinverter. So configuration is like this. Okay, this is a string. We are always talking about string. So you might see this kind of inverter ABB and different companies. This is a string inverter, and these are the microinverters. Each modules are connected separately to the uh, each inverter. So this is a microinverter. Okay, so you can see this difference, because I always advise students and people working with solar PV system. First thing, we have to identify the component. By looking at the component, we can able to explain someone what is this, why we are using this. We no need to explain how it's functioning. It's sometimes it's difficult to explain how the inverter is functioning. It's okay, but we have to say what is the purpose, and why we are using, and what size of this, what size rating, and all sort of general information is needed to explain. Okay, the last thing is the power optimizer. This is not the inverter, but it's come under category of helping inverter to optimize the power. The power optimizer are somewhat in between string inverter and microinverter. So in between these two. So because the problem is microinverter is expensive, because each module you are going to install the inverter, small inverter, so it's expensive. The total project cost is expensive, so we can go for the power optimizer. Essentially this is a DC converter. So what the power optimizer will do, see, it increase the current. So every module connected with a power optimizer. So based on the central inverter, the string inverter, how is it need the power, the current rating. So it optimize the current, or increase or reduce the current. Is a DC converter. If you electrical students, you can clearly understand what is the purpose of DC to DC converter. So DC to DC converter is actually, you can increase the DC current or you can reduce the DC current. Okay, so usually most of the time we are increasing DC current and send it to the central inverter. So power optimizer is electronic device in house, small plastic boxes. They ensure each solar panel in array producing power at its maximum potential. So we know that the maximum power point. We in the IV curve we study that the maximum current and voltage appear at the maximum power point. So we need to provide that maximum current to the inverter. So the power optimizer work in conjunction with the central string inverter, which converts the DC power output of the solar PV. Okay, the string of solar panels in array without power optimizer can suffer low power output. Okay, if you do not have a power optimizer, the low power output, the output maybe goes low. So in order to increase the output, when one panel again, if one solar panel is say that the total output will be low if you do not have a power optimizer. Simple. Now if you have a power optimizer, you can get rid of that shading problem. But another household, if you have a rooftop, you are saying that I don't have any shading problem, then you don't need to worry about installing the power optimizer, or you don't need to worry about installing a microinverter. You can go with a string inverter, or you can go with only central inverter, one inverter. Okay, but when you have a shading issue, each panel has to be taken care of differently. Then we go for a power optimization. So if you have a partially shaded condition or need to install with multiple orientation to the sun, power optimizer can be a smart option. So orientation problem, the sun, your roof, the sun orientation problem, if you have, then it's a good advice to go for a power optimization. While microinverters solve the same shading and roof orientation problem as power optimizer, they are more expensive. The problem is, if you have a microinverter, that solves the problem of shading orientation, but the microinverters are expensive. So this is the picture how the optimizer connected. So each module is connected with the optimizer, power optimizer. Okay, you can this is a power optimizer connected with each module, and this is connected to the inverter, the power optimizer then connected with the inverter. So this is the how it's connected. So in summary, what we have studied today is three inverter basic function. Many people knows that it's convert DC current into AC current. Now we have three types, that's string inverter, microinverter, and power optimizer. So as I said, string inverter we are using if you have a large size of installation, like more than 20 kilowatts installation, we need to use a string inverter, because we probably have 2-3 strings, separate strings. In some houses you have multiple roof. So usually solar company people, they install panels, set of panels in one roof, and another set of panel, another roof. I mean, roofs are like different areas, different orientation. So they install set of panels in one roof, another set of panels in another roof. So it means like they have you probably have 2 or 3 strings based on the orientation. So in that case, you can go with the string inverters, and usually string inverters we are using for more than 50 kilowatts panels, or even some places 30-40 kilowatts. You can think about string inverter when you go for more than 20 kilowatt panels. Okay, so then definitely for 100 kilowatt system we definitely need 3-4 string inverters. Okay, so string inverters increase the output of a particular string. Okay, it taking about a particular string. So I mean your panels are distributed to 2 3 areas. So if one area affected, the other area will not be affected, other areas is still working. So you can simply understand that the string inverter dividing your total project, let's say 50 kilowatts project, into 10 kilowatt 10 kilowatt into 5 sets. Okay, so if one sets is affected, the other sets are not affected. So that is the reason we are using. Affected by shading, affected for failure, anything, the other areas will not affect it. Then we go for a microinverter. Microinverter you can install for even 1 kilowatt system. The reason we are installing microinverter, like if you have a shading issue or intermittent problems in your solar module, then the microinverter will take care of each module separately, so that, as I said, the series in the series strings, the current flow is a problem. If you are connecting all the module in series, current flow is a problem, because if one module is shaded, then the other module current rating also low, become low. So this problem is avoided by each module immediately converted into the power output, immediately converted into AC current at the module itself. Okay, that is a microinverter. But the problem of microinverter is expensive, because each module you have a inverter, so it's expensive. Then we go for because this is expensive, we go for another option, that is a installing power optimizer plus the inverter. So this combination will help to optimize the output as well as maintain the cost moderate. So that's all for today video. Please subscribe this channel, then only I can provide this kind of in-depth knowledge and understanding about solar panels and as well as other disciplines. Thank you very much again. Please subscribe, and we'll see you in the next video.